Hi, my name is Evan, and today I'm here to solve the biggest mystery of the classic jewel smashing game, Bejeweled. So, you may be wondering, what is the biggest mystery of this game? There's a lot to not know about it. So, I'm not talking about any of these mysteries, such as, is there a kill screen? Why are there no black jewels? Where does the name come from? Was the game created by God to punish me? Is there a sequel? No, we've got something bigger to talk about, which is, are the jewels random? Does the game pick which jewels it's going to give you based on some algorithm, or does it just pick one at random? Today, we're going to find out. Where do the jewels come from? Are they up there? Well, we'll see. Using reverse engineering, because sadly the creator of this game, Mr. Cap, was recently killed. He actually died in a electric surfboard accident in Florida. It wasn't COVID. So basically, reverse engineering is where you take some machine code, which is just binary instructions that the computer can understand, and you turn it into regular code that hopefully humans can understand, like this C++ here. So the first step of reverse engineering is you need to get something to reverse engineer. So I just Googled Bejeweled. It turns out MSN Games is still a thing. So went to this very nice, legitimate looking website. All these buttons look very real. Yep, another real button. Got a nice Jewel or off-brand Jewel ad. That seems smart. So we need to, enable Flash, of course. So the next step is to, so we got the game running, and now we need to download it. So you can't just right click on it, so you have to use the web inspector, and you can go to the network tab and you can see a list of all the resources that a web page downloads. Very handy for like grabbing images and in this case flash files. So we need the SWF file and we need the XML file in order to run the game locally, which we'll do later. So once we've got the files, we need to turn that machine code into something we can understand. So I googled around and found this tool called Flasm, which just translates the machine code into assembly code, which is slightly easier to read. I looked for a decompiler that would actually go all the way to giving us ActionScript code, which would be a little easier to read. But Flash is not the most popular technology right now. So it's pretty hard to find things like this. Seems like maybe there was an IDA plugin that I could have used, but I'm not going to buy IDA for this dumb project. So downloaded Flasm. Oh, one fun bit is that I tried to use the binary, but this thing is so old. It was for PowerPC Max. Who remembers PowerPC Max, right guys? Nobody. So downloaded the source, compiled it with a quick make, and I found the disassemble Swift files to the console. So yeah, I'm sure we don't need any of these other stuff, right? So this is the command, pretty simple, and then I just open Bejeweled or temp to see what's inside. Turns out it's pretty easy to read. Some assembly language strips out all the strings or puts the strings at the top in some sort of table. This is actually pretty easy to understand. You can pretty much just read this. The structure is a little weird because it's Flash, so there's like movies and clips and frames and stuff. I don't know what most of this means in like a coding context, but it turns out we don't need it. There's also functions in here, which is nice, makes it much easier to understand. So I started digging around in here. specifically, I searched for instances of the string random, which is Flash's random function, and I found a few in a few functions and tried to figure out, just like, step through this, figure out what all this means. So one thing you might be wondering if you've seen code before is, where's all the code stuff, like the symbols and dots and all that good stuff? Where's the plus signs? And that stuff isn't here because this is assembly language. So all that stuff is implemented. It's like the compiler takes all that stuff and translates it into assembly language, which is like a much simpler language that you can implement in hardware. So here's a few of the operations that this virtual machine supports. The Flash virtual machine is a stack-based virtual machine. It's got a few operations. It's got more than this, but this is like gives you a flavor. So the idea is that there's a stack of things, of like values. So it can be a string or a number or some other stuff, an object. And so this is how you operate on it. I'm not going to go over these because they're boring, but they're very simple operations. You'll notice, like, if you want to set a variable, that's going to require like pushing the value onto the stack, or I guess first you'll push the name of the variable, then you would push the value. So it's like push the string x, push the number 3, and then you call set variable, and that would set x to 3. And that's a lot more code than like x equals 3 in Python, for example. So it's a simpler language, but more verbose. So I just looked like at the code and reverse engineered it. So like here you can see there's some assembly language. I'm not going to go over this, but I added some comments with what it does. So anyway, I found this snippet of code in a function called remove marked gems, and what it does is it moves down the gems that are falling, and it generates the new gems. So if you notice down here, well, I've got a highlight. Oh wait, no I don't. So we see this gem z equals random types plus 1, and that's it. So the assembly language is right above it, but types is the number of different types of Joule types in the game. And when you do random, it gives you a number between 1 and 1 minus the number that you give it. So if you give it the number 4, it will give you 0, 1, 2, or 3, but not 4. So then we have to add 1 because of reasons. So that's unfortunately it. It's just purely random. So to confirm this, so I was pretty sure this is the smoking gun. So to confirm this, I just threw away the value that's given to us by random with this pop, and then pushed a 1 to show the first gem type. So let's see what happens when we run this. And that's it. As you can see, the first gem is apparently yellow. Also, the game wasn't really designed to operate in this mode, so you can see the gem explosions just keep getting bigger and bigger. It gets kind of like it gets pretty annoying after a while. So we'll move on. That's it. Case closed. Nothing more to know. It's the most boring answer. It's actually random. Or is it? Technically, it is not, in fact, random because it's a pseudo-random. It's a computer. It doesn't have a dice inside that it can roll. So there are some algorithms that produce numbers which are predictable. Like if you know the input, you can guess the next number, but it seems random. Like it's random enough. Looking at it, you're not going to detect a pattern. So I wanted to do something with this and create a deterministic Bejeweled hack where it would just give you the same gems in the same order every time. So the board would look the same and the gems that come down are the same. But it turns out Flash is too dumb for that. So there's no way to seed the random function. So I thought about trying to reverse engineer the interpreter, and then I realized that was super dumb, so not going to do that. So in conclusion, the gems are random. There's nothing more to it. And reverse engineering is fun, and you can answer some questions about code, even when the creator has died in a tragic Florida-based accident. Alright, well, I guess I should say something about commenting, and subscribing here, but mostly I just want to be done talking into this microphone, so I don't know, God be with you, something